Good morning to everyone. Hello. Today just I will discuss about just one problem of the already I have discussed in your class, linear programming problem, or that is the unit 5. Just see, this is unit 5. Linear programming problem. Or in short form, we saying that is LPP. Just we'll discuss about the concept of the linear programming problem and how the question will come in the examination. What is linear programming? It deals with the optimization. Linear programming, first point, it deals with the optimizations. And this optimization that may be maximization or minimization. Maybe maximization or minimization. And this deals with maximization or minimization, that is called as the LPP. Or this function is called as the objective. So for creating any function into the LPP form, first we consider objective functions. And this objective function is defined or deals with optimization that may be maximization or may be minimization. So whenever we define the objective function, we can say that it deals with the optimization or it deals with the maximization or minimization of the given LPP. So first of all, when we start any business or any program or any things, then first of all, we choose the objective, our objective functions. And after objective, how to success the objective. This is our objective and how to success. How to success. Our objective. The process of success is called as the constraints. The process of success is called as the constraints or arrangement of the certain program is called as the constraints or called as the linear inequalities. The linear inequalities and objective functions make a LPP. Linear inequalities and objective functions. Objective functions, including linear inequalities, these two parts including is called as the LPP, or linear programming problem. So just one general formula General formulation of LPP. What is the general for? Question number 1. What is the general formulation of LPP? General formulation of LPP. Just remember this question. General formulation of LPP. That means objective function we consider first of all. And your objective function we choose the maximum Z or minimum Z. That is C1x1 plus C2x2 plus that Cnxn. And linear inequalities are constraints. Constants we define here. A1x1 plus A2x2 plus that plus Anxn is less than equal to B1. C1x1 plus C2x2 plus that plus Cnxn is less than equal to B2. And continuing this process, Cnxn plus Cnx2 plus Cnxn, all these terms is less than equal to Bn. Just see this value. Objective function and constants when combined, this is called the linear programming problem, or this is the general form of the LPP. Here all the variables we have considered x1 and x2, x3, all are getting positive. That is the condition most necessary. Then it is called as the linear programming problem. So any inequalities, we know that there is less than or equal to or greater than linear inequalities. What is the type of inequality? Suppose linear inequalities. We have already studied in the class 9 or class 10 the inequalities condition that may be suppose 2x1 plus 3x2 plus x3 less than equal to 5. This is one linear inequality. Less than equal to is called as the linear inequalities. Or x1 plus x2 plus x3 greater than equal to 6. This is also called the linear inequalities because this is symbol the greater than equal to. Or x1 plus 2x2 plus x3 equal to 5. This is also equal to conditions. So these three types is called as the inequalities. If any symbol like less than equal to or greater than equal to or equal to symbol is there, then that is called inequalities. Due to power of variables is 1, so that is called linear. Due to power of variables of 1, it is called linear. And present in this inequality, so this is called linear inequalities. Why we say that the equations are linear inequalities? Because all the variables having degree 1 and all the equations are in the form of less than equal to symbol or greater than equal to symbol or equal to symbol, then we can say that is the linear inequalities. So this is linear inequalities. Any problem is here given? Solve the linear inequality by using the graphical solutions. One is there. So objective functions and constraints optimization of the problem I have already told here. Solution process of the linear programming problem. The first one method we have to utilize here first, graphical solution. In the case of graphical solutions means this type of solution is present here. If any equation is less than equal to symbol, means all the variables here, x1 and x2, x1 greater than equal to 0, x2 greater than equal to 0. So greater than means this the quadrant or fourth quadrant are there. So first quadrant only positive and positive. So all the solutions are present only for the first quadrant. Solutions will be present only for the first quadrant because all variables are positive. If x1 plus x2 less than equal to 5, means this is this type of symbol less than, this is a line, suppose this line, suppose x1 plus x2 less than equal to 5. Less than, that means it represents here only which region? In which region we have to consider? See, this region only. From this point to this point, only this region. First quadrant represents this area. This type of area I have to see here. This is the region up to this. Less than only for the first this region. This is the region we have to choose here. Only this region. If any symbol is represented here, like this, suppose greater than equal to is there. So, greater than equal to symbol we will represent here. Like this. If any graph is in this form, the greater than means this is line. Only not consider for the lower part of the value. This is upper part only you have to consider. If x1 plus of x2 greater than equal to 5 is represent, this is x0, x1 is 0, x1 0 and x2 is 5. Then this is 0, 5 vertices. And this is 5, 0 vertices. And symbol is greater than equal to 5 means this line we can draw first. Then upper part region is your visible region that move in the upper region only. When x1 plus x2 is greater than equal to 5. Then it moves only for the upper half of the plane. So one example we need to solve here. Suppose one line this type of graph and this is this line of graph and another line is this type of graph. All are less than equal to symbol. So this is the common region here. This region is common region. Just dotted line, just you have see here. This is the common region. O, A, B, C. So this is the common region for this graph, which is less than equal to this graph, also less than equal to. Then both the graph have a common region. That common region O, A, B, C. So O, A, B, C is called the feasible region. O, A, B, C called as feasible region. So just remember here, the common region of the graph is called feasible region. The common region of the graph called as feasible region. In solution of the graph is called feasible solution, or that is called optimal solution. Any point of the feasible region gives the optimal value. Any point, suppose there is a points of B, there is a points of C, there is a points of O, that is the points of A. So O point is given, A point is given, B point is given, C point is given here. Any point of A, O, A, B, C gives the optimal solution. Any point gives the optimal solution. Either A or B or C or O, any point gives the optimal solution. That may be maximization or minimization of the objective function. It's called optimal solution. It's called optimal solution. So clearly remember here, any point O, A, B, C gives the optimal solution. Then it is called optimal solution or feasible solution, optimal solution or feasible solution. So just remember everyone, what is optimal solution? Question is arise here, what is optimal solution? Or what is feasible solution? Just remember, feasible solution, any point in the feasible region gives the optimal value then of the objective function. It's called optimal solution. The answer, any point in the feasible region any point in the feasible region that gives a optimal value called as optimal value of the objective function. Called feasible solution or optimal solution. The next, just one example we need to show that. Solve the following linear programming problem graphically. One example here. Solve the linear programming problem or LPP by graphically. Question is that maximum z is equal to 4x plus y. Subject to constraints x plus y less than equal to 50. Three x plus y less than equal to 90. X and y both are positive. So just you remember a solve for graphical method. How to solve this value? The question is that equation 1 just naming here. Equation 2 is naming here. First you consider equation 1. What is the equation 1? X plus y less than equal to 50. So x plus y less than equal to 50 here given. Here put x is equal to 0. What is the value of y? Now y is equal to 50. Then choose the vertices here 0, 50. If you put y value is 0, what is the x? That is also 50. So this vertices is 50, 0. This is the first line equation. 3x plus y less than equal to 90. Three x plus y less than equal to 90. Next question is that 3. So just you remember here. Okay, so just we come here. Okay, the next question we will going to here discuss. So here put x is equal to 0, then just you getting here y is equal to 50, and vertices is represented here 0, 50, and another one is y is equal to 50 or y is equal to 0, just put here. Put y is equal to 0. So just next step we just discussed here, y is equal to 0. Then what is x? X is equal to 50. So vertices is considered here 50, 0. This is equation 1. Equation 2, 3x plus y less than equal to 90. 3x plus y less than equal to 90, that is equation 2. Put x is equal to 0 here. Then what is the result? X is equal to 0, then y is equal to 90. Then vertices is 0, 90. And put y equal to 0. Then x is equal to 3x is equal to 90. Then x is equal to 30. In here problem, when you put y 0, then 3x is equal to 90, then x is equal to 30. Then its vertices is 30, 0. So two line equations, we got all the vertices. Now we need to draw here this figure. This is x axis and this is y axis, and just take 10 interval for and 20, 30, 40, 50, 60, 70, 80, etc. 10, 20, 30, 40, 50, 60, 70, 80, and 90. So you choose the first vertices. In the problem, 0, 50, 50, 0, first equation. 0, 50 is this point, and 50, 0 is this point. Then draw this line. Just you join and drawing this line. Less than region means this region is less than here. Only for the first quadrant region. Up to this region. Again, second equation contains, this is equation naming as x plus y less than equal to 50, or this is x plus y is equal to 50. Second equation vertices becomes 30, 0. This is 1. And 0, 90. This is 1. Then this is the line which intersect this point. This is also less than. This is a graph which is less than symbol. So this is 3x plus of y is equal to 90. So this region means this is the region we have to consider first quadrant. Only of this part region. Only of this region. Just naming here O, A, B, C. This is your common region or common feasible region. So feasible region here. Feasible region. O, A, B, C. Actually, objective is to maximum of any point. That is the optimal solution. So we have already know the vertices of O vertices 0, 0. A vertices 30, 0. But B vertices we not found here. So B is the point of intersection. B is the point of intersection. Which intersection? X plus y is equal to 50 and 3x plus y is equal to 90. And solve these two equations. Just subtract, cancel. Minus of 2x is equal to minus of 40. Then x is equal to 20. If x is 20, y is equal to 50 minus 20, that is 30. So B is the vertices 20, 30. And C is the another vertices already given that point. 50, 0. 0, 50. So we need here objective value of Z, but we are searching for the maximum value of Z. And that is our plan because our objective is to find the maximum value here. 0, 0. Z is given here for x plus y. Z x 0, y 0. Then this is the value of 0. Next x 30. Z value become 40 into 30. Then 1200. 20 and 30. Then 20 into 4 plus 30. That is equal to 120. Sorry, this is 0. 4 into 30, not 40. So 120 is this is value. And this result is becomes 120. 4, 3, 120 and 4 to 80, 80 plus 30, 110. This is 110 and this is 50. So our objective is to evaluate the maximum profit for which point? A point got the maximum profit because maximum value Z is 120. So our plan must be satisfy this criteria when used, then I have getting the profit of maximum. So x is equal to 30 and y equal to 0 plan we have used and maximum Z is equal to 120, right? So this is our solution of the graphical method of the given LPP. Okay. So thank you to all and you will prepare according to that. I have some homework also I have given you. Certainly I have some problem also given to you and different type of question also provide you and you will prepare according to that. Thank you for all.